Right, so next we have the constant, not constant, the sum and difference rules. So the sum and difference rules say the following. Right, so they say the following. The sum or difference of two differential functions f and g is itself differentiable. Moreover, the derivative of f plus g or f minus g is the sum or difference of the derivatives of f and g. So basically what we have is the following. If you take the derivative with respect to x of the sum f of x plus g of x of these two functions, and you know that both of these functions are differentiable, then what you get is the following. You get that the derivative of f plus the derivative of g is the same as first doing the sum and then taking the derivative. So you could do the sum first, then take the derivative, or you could take the derivative of them independently and then add them up together. Similarly, if you were to subtract first and then take the derivative, that would be the same thing as taking the derivative first and then subtracting. Okay. Right, so these two rules can be extended to any finite number of functions. For instance, if you have something like this, let's say somebody on the train gives you the function f, and f is given to you as g of x minus h of x plus k of x, then the derivative f prime of x is going to be simply the sum of the derivative of g of x minus the derivative of h of x plus the derivative of k of x. Okay, so let's see this in action. Let's look at an example. If somebody gives you the following function of a polynomial, x cubed minus 4x plus 5, notice that here we have more than one function. You know, you could say that your g of x is x cubed, you could say that your h of x is minus 4x, and you could say that your k of x here is just 5. Remember, these are all independent functions. You know, one is linear, one is cubic, one is constant. By the sum and difference rules, I now know that I can actually take the derivative of each piece individually and then add it up together, and that will be the derivative of f of x. So f prime of x is simply equal to the derivative of x cubed. Well, what is g prime of x? That's simply 3x squared using the constant multiple rule. What is the derivative of h of x? Using the again the constant multiple rule, that's simply just -4. Actually, for g of x we use the power rule, not the constant multiple rule. For k of x, this derivative constant, we explained in lecture 8 that the derivative of constant is simply the constant. Actually, it was in earlier this lecture. So what we have here is that the derivative of f is simply the sum of the individual derivatives. So that's 3x squared minus 4. The derivative constant is 0, not 5. 0. So it's 3x minus 4. The limit of a constant is just a constant. Okay, let's do another one. What about g of x equals, let's say negative x to the 4 over 2 plus 3x squared minus 2x. Well, this one looks a little bit more complicated. Well, let's say that f of x in this one is equal to negative x to the 4 2. Let's say that k of x in this one is going to be equal to 3x squared, and let's say that h of x is equal to negative 2x. Well, f prime of x is equal to, by the constant multiple rule and the power rule, it's going to be equal to negative 4x cubed over 2, but that's, you could divide by 2. 4 is divisible by 2, so this is equal to negative 2x cubed. K prime of x is going to be equal to 3 times 2x, which is equal to 6x by the constant multiple rule, and h prime of x is going to be equal to simply negative 2. Okay, so what do we have here? We have that g prime of x now, the derivative of g, which is what we were interested in, is simply negative 2x cubed plus 6x minus 2. We simply just put everything together. All of these. Okay. Let's do one more. Just for the sake of it, let's assume, so let's do another one. Say g of x equals 3x to the 4 plus 5x minus 3, and f of x is equal to 27, not 27, it's too big. I'll do 15x 3 minus 2x plus 1. If somebody told you to find d dx of f of x plus g of x, well, we now know that this is the same thing as simply doing f prime of x plus g prime of x. Well, f prime of x we can compute. So I'm going to just simply put the derivatives of each one underneath. It's the derivative constant is 0. This is going to be minus 2. This is going to be 45x cubed, x squared. So for f prime we have 45x squared minus 2. And then I said plus, and then g prime, and I'm going to again put them underneath. This is going to be 12x cubed. You could check this using the rules that we have discussed so far. 5x, and then this is 0, so it's going to be plus 12x cubed plus 5x. Now we could add like terms, but there is no other cube term, so I'm going to put this in the front as the leading coefficient, as the leading term, plus 45x squared minus 2. So d dx of f of x plus g of x is equal to this, to all of this. Right, so that is how you use these sum and difference formulas when looking for the derivative.